All right, so continuing with our discussion on functions, I showed you a bunch of string functions. Now let's take a look at some functions we can use with numbers. So just like on a calculator, you've got some things you can do with numbers. We can do some stuff with numbers in. Obviously, you know how to do some basic math, right? Addition, subtraction, multiplication, division. Those are easy. You just put the operator in there, so that's not too difficult. And we'll use some of that here when I show you a few of these. But let's take a look at the round function. So we know what rounding numbers is, right? So let's say I came up with some examples here. So let's say we're looking at our books table, right? So we know we always seem to use the books table for this, but let's say we know our title and our retail are columns in books, right? So let's see what they look like. All right, so there's the retail cost of the book. So if I wanted to round the retail price, right? So let's give me 1 second. Excuse me. Something stuck in my throat. So let's say we wanted to round the retail price. So I can just do round retail, and I'm going to round it by 1, right? So I'm going to round it to the ones place. Let's see what that looks like. All right, so we go from 30.95 to just 31, right? It rounds the number up. We can also do round retail 0. See what that looks like. Okay, so that does the same thing. But now let's do round retail -1. So what this is going to do is round it down instead of rounding it up. All right, so let's see if that works. There we go. So 30.95 goes down to 30. 22 is rounded to 20, right? So that rounds it down to the nearest tens place. Okay, so that's the round command. Most of the time, you probably just want to use round 1. That's probably the more common use for that function. Now, another function we could use is truncate. So we could do the same thing. In fact, let me just copy and paste this. So truncating is a little bit different, where round rounds the number, right? Truncate sort of just chops it off, right? So it just chops it off at a certain position. So let's try the same 3 functions here, but using truncate. In fact, you know what? We'll just do both. That's right, we can't do both. Well, that's not true. We could do both, right? Let's do a union, right? We'll show both. All right, so here's my, let's see. All the ones that are round numbers, I think, are going to be our, let's see. Oh, you know what? It combined them all, so it's probably best not to do that. Let's just do a truncate. Okay, so when we truncated, as you can see here, it just truncated the 5. It just chopped the 5 right off. With this one, it chopped the 0.9, right? And then here we there's nothing to chop off here, right? Same with this one. Here we get to 59, right? So this one just chops off. It doesn't actually round. Okay, so truncate just chops it off at that position, whereas round is going to round it up or round it down, as we saw before. All right, so another function with numbers. You can do some basic math, right? So we already talked about being able to do division, right? So if I do, I don't know, let's say we want to convert some numbers, right? So let's say if we do, if we have 235 ounces and we divide by 16 ounces, that's going to give us pounds, right? Let's see if that works. So 235 divided by 16 is going to give us the number of pounds. So we know that whatever this is, it's 14.6875 pounds. But when's the last time you bought a bag of Doritos that were 14.6875 pounds, right? Although that would be a heck of a lot of Doritos. But you know what I mean? Like, they don't usually show it in a decimal like this. You usually want to show it in the number of pounds and ounces. That's how most people are used to reading something like that. So Modulus would allow us to do that. Modulus is basically, modulus gives you the remainder, right? So when you divide two numbers, if you just do division, you can get the whole number, which is easy. We can just truncate to get the whole number, right? So if I want to find out how many pounds that is, the first thing I could do is just truncate 235 divided by 16. Right? That's going to give me the number of pounds without a decimal. But now I got to figure out what's the remainder so that I can show the number of ounces. How many ounces are going to be left over once I calculate pounds? So to do that, we're going to do mod, or modulus. This is also called modulus. You probably learned about this in other programming classes. So we'll do the same thing, 235 divided by 16, but this is going to be ounces. Oops, got to take off the pounds here. And for some reason I got rid of pounds over here. There we go. Oh crap, I forgot to highlight it. Sorry guys. Let me highlight it for you. Well, that should work. Oh, I always forget with truncate. I think we have to add. Yeah, there we go. I'm going to add the 0. That just tells it to truncate it to the nearest whole number, right? By putting the 0 there, which we just learned about a few minutes ago. So let me highlight this. So now I should get... Oh, wait a minute. Did I do that right? Yeah, that should be the nearest whole number. Oh, that's right. I always forget. We don't divide this. We're passing in two numbers, right? It's two arguments. It's the top and the bottom of the division, right? The denominator is 16. So let me do this when I call it the right way. So modulus, you call it with two arguments: the number, then what you want to divide it by, and then it's going to give you the remainder. So here we have 14 pounds. So 235 divided by 16 is going to be 14. If we chop off the all the decimal points, and then we divide it again, but only show the remainder, and we have 11 ounces. So that's going to be the modulus function. What else do I have to show you? Absolute value. So we have to do an absolute value. So absolute value is going to basically ignore negative, right? So if we come up with a negative number, it's going to show a positive number. As an example, and this is from your textbook. So from your textbook, they do pub date, and then we're going to select the system date from books, or category equals children. All right, so we're going to get the date that it was published and the current date. It's not category, it's category. Sorry, my spelling is terrible. I just spelled the column name wrong. So we have our pub date and our system date, and what we're trying to do is figure out how long ago this book was published, right? So when exactly was this book published, which was because our data is pretty old in these examples, it's going to be a long time ago, right? But let's say I want to get the difference between these two. So well, that's pretty easy. I could just subtract them, right? So if I do pub date minus sys date, right? So if we subtract those two, let's see what we get. All right, so then we get the number of days, right? Of course, Oracle is giving us a really exact number here, right? This is pretty precise, because this, even though it's only showing us the date here, the time is also in there, right? We just don't see it here. I think we don't really talk about dates too much yet, but the time is actually in there as well. So it gives us a really, a high level of precision on the actual difference between the two. So the first thing I probably want to do is I want to round that, right? So let's round it. We learned how to do that before. Whoops. And in this case, I don't really have to pass an argument because we're just going to round it to the nearest. So this should round to 4404. This is going to round to 4534. I could have also just done truncate, right? That would have worked as well. So that should give us something a little more reasonable, right? Because we only care about the number of days. So that just gives us the number of days. Now, the problem here is they're negative, right? So that's the whole point of this little exercise. So if we do absolute, now remember, we can nest our functions, right? So I'm just going to nest this in here. So now it's going to round it first, then it's going to take the absolute value. So what I should end up with is just a whole number that's not negative, right? So here's just doing the math. It's kind of ugly. We rounded it, but it had a negative in front of it. So here we got rid of the negative by using an absolute value. Now, of course, we could have gotten rid of the negative just by switching them, right? We could have just reversed how we did this, but I just wanted to show you an example of how that works. So let's switch gears a little bit and look at dates, right? I just touched on dates and how they're treated a little bit different. Dates are not really integers, and they're also not really strings, right? They have their own little data type, but a lot of stuff you can do with dates. So let's see, what can we do here? We are going to what kind of date functions do I need to show you? So the first one is months between. So months between can show you the months between two dates. Let's give it a try. So I'm going to do, I'll tell you what, let's do it from dual first. So I'll select, I don't know, let's see if I can do, let's see. Well, let me try to get my my date of birth, right? So let's do, now I can't just, so you would think I'd be able to do, if I was born on May 23rd, so 23 May 79, you would think I could just do this, right? But it's a little ambiguous, and the system's just going to think that that's a string. So I have to use a function. So, and I think this works. I think we can use toDate. Let's try it. So if we do toDate, and then I don't want to just do 79. Actually, this format just hurts my eyes. I like doing it like this. So 19790523 from most or least significant to most significant. So then I have to mask it, so I can do YYYYMMDD. As my birthday. Let's see if that works. I don't remember if toDate is the right function to use here. Yeah, I think that did work. So let's try to do, first let me just see how many days it's been since I was born. So I'm just going to subtract sysdate. Right? So if that toDate function worked, it should tell me the number of days since I was born. There we go. So I was born 14,200 days ago. Well, that's great, but that's not very useful, right? Probably what I really want to know is how many months it's been since I was born. Although that's really not terribly useful, but for this exercise, let's see how many months it's been since I was born. So I'm going to do months between, and we'll pass in the two dates. I'm just going to get rid of this because we don't need it now. See if this works. All right, it's been 466 months since I've been born. Right? Now, here's another example. Let's do vacation time, right? So let's start with 2018. 01. So I want to find out how many weeks. I don't know if this works or not, but we're going to give it a try. So let's see if I can figure out how many weeks there are between the current date and the beginning of the year. Oracle doesn't have weeks between, so we're kind of stuck with months between. But that's okay. So let's say we put months between in here. So it's been 3.23 months. Now let's say I know that I earn, I don't know, let me just take a guess here. Let's say that you earn 2.5 days of vacation. Oh, I'm sorry. No, let's That's not much vacation. Let's say you earn 10 hours of vacation for every month that you work. So that would be 120 hours of vacation a year, which, gosh, that sounds like a lot, but I don't know. But anyway, let's just give it a try. That sounds like a pretty good deal. So times 10, this is going to give us the number of hours of vacation that I've earned so far. All right, so this our fictional employee here has earned 32 hours of vacation so far this year. That seems about right. That's pretty good. You know, like 3 weeks a year, give or take. All right, so that's months between. Okay, we can also add months. So we could take a date and just add a month to it. I'm going to use the example from your textbook. So in your textbook, we're going to look at the publishers table. So we have pub date, well, let's see. So I think what they did here, I'm just looking in your book, so we have our pub date. They're going to add months to 01 December 08 18. So they're going to add 18 months and call that the renegotiate. The renegotiate date. And then we're going to add months. Oops. Pub date 84. And that's the drop date. So I guess the date that we should be dropping that from our inventory. All right, let's see what that looks like. All right, so we have our title. There's the published date, right? So this book was published in 2005. We add 18 months to 2008, and we get an error here. It looks like because well, I'm not quite sure, but this is clearly not what we intended. But the drop date looks to be correct. So this is 84 months after the published date. So this book should be dropped from inventory in March of 2013 because the book is going to be too old, right? Not really sure what they were trying to do in your book with the renegotiate date. Why it was why we're using December of 08 and then adding 18 months to that. But it doesn't look like that worked anyway. But like I said, I think if I were doing this, I would probably use a real date here and use to date. In fact, let's give that a try. So instead, let's do so they want to add 18 months to December of 2008. So I'm going to do to date 2008 12/01, and my format is going to be YYY MMDD. Let's give that a try. Oh, I'm missing a Y on here. Oops. There we go. We need to use 4 Ys. There, that looks a little better, right? So I'll tell you why it didn't work, because it was ambiguous, right? We passed in just a 08. It didn't know what that meant. It meant I think it just assumed that we meant year 01, right? Or year 08 rather. So then 2 years later, 18 months later, it would be year 10, which is obviously not what we intended. We want it to be 2000. So using to date is a little less ambiguous, so that's what I always use rather than the ambiguous format that Oracle uses. I really don't like the default format in Oracle, but I don't want to change it for you guys because I think it'll confuse everything. All right, so another function we can use is next day. So as an example, let's say I wanted to select my order numbers and the date for those orders, then show the next day for the order date that falls on a Monday. Oops. All right, let's give this a try. So you can see here we've got our order number and the date that they ordered it. And this is going to tell us the next day that is a Monday. So what's the Monday after the date they ordered that book? You can see these are all the same. I should probably make this larger so we can see more rows. There we go. Of course, it looks like all of our orders are from the same couple of days. So Monday, April 6 is the next Monday after that order date, which is a while ago, right? 2009. Good Lord, that was almost 10 years ago, right? Well, 11 years ago from when I'm recording this. But so next day just tells you what's the date on the next occurrence of that day after your date. So just another little useful function. We already talked about toDate, so your book does talk about toDate, which allows you to convert a date. If you look in your book, there is so when I call the toDate function, right? So when I did my birthday, for example, I did select, oops, sorry. When I used the toDate function, I wrote my birthday as 1979-0523, which is the ANSI format. That equal sign should be a dash. So that's the ANSI format. I have to tell Oracle what format I'm using, so I put a mask in like this, and it knows that this part is the year, then the next part is the month in 2-digit format, then the day in 2-digit format, right? And that's going to return my date. Of course, Oracle is going to convert that to its fancy format. Well, its ambiguous format internally, but there it is. So, yeah, notice how Oracle flipped this around, right? Now in its default, it puts the day first, then the month, and then the year at the end. Okay, so with toDate, if you look in your textbook, there is a chart that shows you all of the different values you can use for the mask. So Y is the 4-digit year, but YY would be a 2-digit year. And then just year spelled out would be if the year was actually written out, like 2009, all written out. BC or AD, if it's 2009 AD or BC, which, gosh, that's probably not too common. I can't imagine why we would care about dates that are that old in a database. I guess it could happen. I can't think of a good example of that in the most normal business. But in any event, there's all these different formats you can use. Like, for example, the uppercase D, you would write the day as Wednesday, Thursday, Friday, something like that. So in any event, that would be the different formats. And again, that's going to be in your textbook. I don't want to go through all those. But dates, you can do some of the same things that we did with integers. You can also do with dates. So for example, because at the end of the day, dates are really kind of, in a way, they're sort of numeric, right? It's kind of a halfway point between being numeric and being string data. We read them as strings, but they really are under the hood. They're actually kind of numbers, right? So for example, if I wanted to select the pub date from books, right? We've been doing this a lot, but here's my published date. So let's say I wanted to show the month. Let's say I wanted to show the just the month that it was published in, not the actual date. So I can round it to the nearest month. So I'm going to round it to, so when we use the round function with a date, we can pass in an argument for what to round it to. I could round it to something else too. I can maybe round it just to the nearest year, right? I just want to know what year was this published. Right? So now, and it's going to look a little strange because it's going to show the full format of the date with the rounding, but this book was actually published on January 21st, 2005. So the month was February of 2005. It just put 01 for the day by default, but really all we care about is it's February 2005. And then down here, all we care about is the actual year that's on the end. We don't care about the first part, right? This is actually wrong. But it rounded it for us, right? It gave us the nearest year. This gave us the nearest month and year, And then, of course, this is the exact date. Why would I use this? You know, if I were doing some reporting where I only need to see the year, or I want to group things by the year or something like that, this would give me the same value for everything done in the same year. So if I could, you know, if I wanted to group something, it'll work. So for example, if I wanted to, I don't think we talked about this yet, but let's say I wanted to show the number of books published each year, and we're actually gonna learn about this next week in the next unit. But if I wanted to count all the records by year, I could group it by year. And if this works, I think this works in Oracle. It should anyway. There we go. So we have 5 books that were published in 2005. I have 2 that were published in 2003. Right? So this shows me the counts for each year, how many books were published in each one of those years. Now, if I tried to do this without the round command, right? So let's say I just put the publish date, right, without actually rounding it. So now I'm going to get something not very meaningful, right? Because now it's just going to show me, you know, every book individually. It just so happened that 1 book or 2 books happen to be published on January 21st, but you know, I'd still have to add up to figure out what the years are, so that's not terribly useful. So that's what the round command does for us, or round function rather. And just like we have a round function, we can also truncate. Let me get back to where I was before. There we go. So we can also truncate our date. So for example, let's see, let's do something a little different here. So we're going to select the title from books. Yeah, okay, so let's say we wanted to figure out, we know when our books were published, and we know when people order our books. So first, let's figure out how to show, both the published date and the date that it was ordered, right? So I have the title of the book, I want the pub date, and I also want the order date. All right, so I want to show these 3. So I know books, the title is going to be in books, right? Then I have to join, right? So I'm going to join which table? So the published date's going to be in publisher, right? So let's think. Oh no, pub date's in books. So I only have to join orders, right? So I have to join order items first, because I have to, the only thing I can join on is the ISBN. So I can get my order items. So I have to get a list of all the things that were ordered on various orders from order items. And I can just do that using the ISBN. If you recall, both tables have an ISBN, right? Now I also have to join to the order, because the order is where I'm going to get the actual order date. So first I have to get the order items, because that's going to get my books table joined to order items, and then I can figure out which orders have those order items. So I'm going to join my orders using my order number. All right, now if I did this right, I should get a nice list here. Let's see if it works. There we go. So here's a book. This is when it was published, and here's the date that our customer ordered it, right? So now that I know that, I should be able to get the months between these 2 dates, right? So let's get the months between the order date and the publish date. All right, here we go. So there's my months between the order date and the publish date, right? So cooking with mushrooms, somebody ordered that 61 months after it was published, which seems like an awful long time, but I guess it's well, that's 5 years, right? So the problem is this is backwards, right? We got the negative sign on there. Let's just go ahead and put another function in here, right? If we put ABS in here, that's going to give us a positive number, right? Because I did it backwards. Instead of reversing them, I'll just use absolute. And I don't care about this fraction of a month. I just want the full month. So I'm going to use trunc to do that, right? I'm going to truncate it, and it's going to work just like it works with numbers, because really this is just an integer at this point. So now that's just a number. Let's see if that works. There we go. So now I've got the number of months. And just to give you a preview of what we're going to be doing next week, which is group functions, I could also, I'm just going to show you that what if I want to know the average number of months old a book is when it's ordered. This is just going to give me one row that's going to tell me what the average is. Oh, maybe it's AVG. I always forget. There we go. So books are ordered an average of 54 months after they're published. So that gives me a good idea of how long I should keep books around. And just as an example, what's the maximum number of months that someone's ever ordered a book after it was published in our little database? 70 months, right? So no one's ever ordered a book over 70 months old. So that might be good, interesting business information to know. Gosh, I know we're running long here on the time this week, but it's a lot of stuff to show you. Your book also talks about regular expressions. So we're done talking about dates and numbers. Regular expressions. I'm just going to show you a really quick example of regular expressions. I don't expect you guys to become experts in regular expressions because they can be pretty complicated, and you'll see why here in a second. But looking at suppliers, oh, sorry, I spelled suppliers wrong. I keep spelling stuff wrong today. Let me try this again. Okay, so looking at our list of suppliers, notice that a lot of my suppliers, they included a phone number in here in the description of the supplier, right? So there's a phone number in there, maybe some other stuff in there. So if I wanted to only show records where the supplier contains a phone number, I can use Regex to do that. Basically, Regex is, and there's a whole bunch of different functions that work with Regex, but Regex is a whole programming language unto itself, and it seems like every database engine has a slightly different implementation of regular expressions or Regex. But basically, what you'll do is you use Regex to search for complex patterns, right? It's all about pattern recognition. So with a phone number, the pattern I'm looking for is any digit, any set of 3 digits that are near each other, followed by either a dash or a period, followed by another 3 digits, followed by another dash or a period, followed by another 4 digits. Well, I can do that with Regex. So first I say look for the characters 0 through 9, look for 3 of them next to each other, and then check for a dash or a dot after that. Then I can say look for another character 0 through 9, but look for 3 of those again, right? And then look for another dash or a dot, right? Either one, doesn't matter. And then I'm going to look for another 0 through 9, at least. This time I think we're going to want 4 of them together, right? And that's it. So that's the pattern that I'm going to look for. So, and gosh, I hope I wrote that right. It's been a while since I used regular expressions. There we go. So it only returned records now that had phone numbers in it. Okay? So that's how regular expressions work. Like I said, in your book they have some examples. I don't expect you to be an expert in this class on Regex. You could take a whole course on Regex if you wanted to. Regular expressions can get really complicated. I shouldn't say a whole course, but I mean, gosh, they can get very complicated. All right, so the next thing we're going to cover is some other additional functions. There's a few that are covered in your book that I just want to cover real quick. Some additional ones, they don't really fall in any particular category. So these are, some of them have to do with nulls, so there's a bunch that have to do with how to deal with nulls. And then we also have some with dealing with strings. So I'll show you how to do those as well. So first, we'll do the Nvl function. So as an example, let's say I wanted to select the order number and the order date. Did I spell that right? There we go. Order date, the ship date. That's it. So we'll select those for now from orders. See if that works. let's see if we can get our order number, the order date. Uh-oh. I lost my session. All right, let me log back in. All right, I got my session back. So I was able to run the command, and you can see here we have our order number, order date, and our ship date. And if we look through this list, actually let's not limit our results, right? And let's scroll through here. So you can see that some of our ship dates are null, right? So there's no value for the ship date, probably indicating that our item hasn't yet been shipped yet. So let's say we're trying to do some kind of a report, and we want to assume, so if if in this report we wanted to, oops, I hit the tab button. Let's say we wanted to show the ship date minus the order date, right? And we're only going to do this. Let's limit this a little bit so we don't see everything. So where our order date is greater than or equal to 03 April 2009. That should work. That should give us a smaller result set. Oh, what did I miss here? Oh, there it is. I forgot to put the where clause in front of there, so maybe that'll work. So this will show us the date. So you can see what happens here is the ship date is correct when I have an actual ship date, but then I just get a null for the ones that are missing, right? If we try to do any kind of arithmetic operation with a null value, you end up with a null, right? So 5 times null is null. 5 times 0 is 0. 5 times null is null. Same kind of thing. And even if you try to add or subtract, you still end up with null if you're trying to do that operation on any null. So nulls will ruin your day. I think I've talked about that before, that nulls can be a problem. So NVL is the function that allows us to substitute something for null. So in other words, the ship date, if I don't want to use, for the ship date, if it's null, instead of using null, I want to return some other date. So I'm just going to return the system date, right? So if ship date has a valid value, it'll just use ship date. But if it's null, then it's going to substitute that with the current date and time. Of course, we're going to get some weird numbers here, but let's see what it does. There we go. So this order that's null, you can see it gave me the difference between the two is 3,292 days. Obviously, it's never been shipped. Or if I shipped it today, it would be shipping 3,292 days late. Of course, this database was made a long time ago, probably back in 2009. Our textbook publisher probably hasn't updated this in a while. So that's how NVL works. NVL substitutes a different value when it's null. So it takes the first argument, and if it's null, it puts another value in for that argument. So another example, this is a similar one. There's also a function called NVL2. NVL2 is a little bit different. NVL2 is going to output. It could take some other action. So in addition to you can substitute if it's null and substitute if it's not null. So it lets you do both at the same time. So as an example, let's say we have our order number. Then we have our order date, right? And then we have our ship date. I should have just left this up before. I don't know why I deleted it. From orders. Now, if you recall, if the ship date is null, right? So taking a look at this, when the ship date is null, that probably means it hasn't shipped yet, right? So instead of showing null, instead I could just indicate whether or not it's been shipped or not, right? So NVL2 would let me do that. So with NVL2, so if this is null, or I'm sorry, if it's not null, we can say it's shipped. And then if it is null, we're going to say not shipped. All right, so now instead of just seeing a date for ship date, we're going to see just whether or not it was shipped or not, right? There we go. So most of this stuff was shipped, but you can see this one was not shipped. This one was not shipped, right? So it substituted, if it's null, it substituted shipped, and when it was, when it's not null, it said shipped, and when it is null, it says not shipped. So that's what NVL2 does. So it's similar to NVL, but we have three arguments instead of two, because we could tell it what to do when it is null and when it's not null. So the first one only substitutes when it's null. The second one can substitute both for null and not null. And you can pick which one you want to do. Another kind of similar function is the null if function. Null if lets you do something if it's null. So as an example, this is going to be a complicated example. So let's say we want to select our customer number and our order number, the ISBN, paid each, and retail. And these are going to be in some different tables. So let's see, we're going to be selecting from our orders table. And whenever we select from orders, we have to join to order items because all the items are on the order items table. We'll do that using the order number because we know that that's both tables from our diagram in the beginning of the semester. Then we're also going to join books using the ISBN. So let's make sure that works. Okay, there we go. So we've got our customer number, the ISBN, the paid each, and then the retail value, right? So what it would cost retail. All right, so if now let's look through this list here. So it looks to me like these all have valid values. I'm looking for something that might have null. So you can see that sometimes the paid each is the same as the retail value, and other times they're different, right? I added a where clause just so you could see some specific examples here. So for example, this one here is $85.45 was what they paid, $89.95 is the actual retail. So if I use the null if, so we can see how this works, null if basically does something if both values are the same. So what it does, so let me put paid each and retail in here. So it's pretty simple. It's going to compare these two values. If they're the same, we get a null. And if they're not the same, it puts the value of the first argument. So basically, compares them. And if they're the same, it just outputs null. And if they're not the same, the first argument is output. It's kind of hard to come up with like a good use case for this, but oh, whoops. Oh, I forgot to put a comma in my column list. Sorry about that. So I forgot a little comment after the after retail. There we go. So you can see these two are the same, so it did null. These two are different, so it output the first argument. Again, the same here at the bottom. These are different, so it output the first one, 85.45. Okay, so that's the null if function. So now let's switch gears a little bit. We talked about these null functions, which are some special functions. I talked about the toDate function. I showed you how to use toDate to convert something, a string to a date. You can also convert to a character, right? So you can convert data to a character. I'll give you a good example of that. Let's say you have actually let's try this with books, right? So if we do select star from books, because books should have some numeric values in here and some date type values. So we have a published date, which is a date. We've got the cost and the retail, right? So the cost is $18.75. The retail is $30.95, which is fine. But the thing is, most customers wouldn't want to see the price like that. They want to see it with a dollar sign, and have it look nice. So we can use the toChar to convert that integer to a character that has formatting. So for example, for the retail price, right? Retail price, I'm going to use the toChar function. We're going to convert retail, and then I have to give it the format I want to use. So I want to have a dollar sign and then the number with a decimal point, just like this, right? So that's going to output the price, but it's going to make it look like money, right? It's going to add my formatting. There we go. So now it's got the formatting. So you basically mask the, you put the number. Now if I wanted to, I could put something else here, right? I could put an asterisk there instead. It wouldn't make any sense because we usually don't put an asterisk in front of money, but in theory it would work. You know what? That failed. I think in Oracle, you only have a certain number of, there's certain characters that you have to put there in Oracle, I think. Some database engines will let you use anything for the mask. But you can also do other values. So another example would be dates, right? So just like we can go from a character data to date, we can take a date and convert it to character data, but you have to tell Oracle how you want it to display. right? So for example, so let's see, pub date. So if you recall, I like to see, so Oracle outputs the dates with just the two, you know, it outputs date, you know, I'll show you here so you can see. If you recall my date of birth, it output it like this. It went 23051979, right? But I prefer my dates to look like this, right? I like this format better. It's a little more intuitive for me. So I'm going to take that pub date, actually just so you can see the difference, let's output the pub date, and we'll output our new formatted version of it. So I'm going to do YYY-MM-DD, and now it'll convert that date to a format that makes a little more sense for me. There we go. So this is how Oracle has the date, or displays the date by default, but I converted it to a string and output it a little bit different. And there's various, you know, with these you can use different different formats. So for example, YYYY is year. I could do, let's do this. Let's do month, day, year, and see what it does. Oh, I forgot to highlight it. There we go. Now it should work. Let's see. There we go. So January, Friday, 2005, right? So month is spelled out. Day is the actual day. You know, so I could do Friday, comma, month, DD. This might look a little better, right? So it'll say Friday, January, whatever, you know, 2000 something. There we go, Friday, January 21, 2005. So different formats. Again, that's all from that table that I talked about earlier. So I showed you that table before. In your textbook, you can see that table of the valid values that you can use, you know, for the formatting. And I'm looking at that table in the textbook right now, and I can see that it does. You can only use the floating $sign. It looks like you can't use other symbols for that, unfortunately. So let me think if there's any of these other ones I should show you. Let's see. So Decode is another example. Let's take a look at Decode. So we're going to select the customer number and the state, right? So here's the thing is, let's just output this as raw data first. So let's say you wanted to store the tax amount for each one of these states, right? So let's say you wanted to output the amount of sales tax for each one of these states, because maybe you're going to calculate the the revenue for these customers, how much you have to pay for taxes or something like that, right? So hopefully you would know the tax rate for each one of these states, and we can use Decode to sort of do this all in one shot. So if we do, so you tell it what field you want to decode, and then you give it the value pairs, right? So the first value pair is going to be CA, and if it's CA, we're going to output 0.8. And I'm just to make this easy, I'm going to put a carriage return in here. Then we do another argument for FL 0.07. And then we're going to end it with 0. Now notice that in this case, really the number of arguments is almost limitless, right? I have my first argument is what I want to decode, and then the following two arguments are the value to look for and the value to substitute, then the value to look for, then the value to substitute, and so forth until you get to the end. And then I got to close my parenthesis. So now it should show me what the tax is. In fact, I'll do this. That way we can see what the tax rate is. Hopefully this works. And it didn't. From keyword not found where expected. You know what? Maybe this doesn't work. Oh, I forgot the comma after state. I always forget that. We have to put a comma between each one of our column declarations. There we go. So Florida shows 0.07, California 0.08, and so forth. So that's the decode function. You could do this kind of similar. You could do this with a case function. So for example, instead of using decode, I could do case, and I could say, let's do this. So when state is equal to CA, oops, then 0.07. And when our state is equal to FL, oops, and 0.08. And finally, else, if none of this stuff is true, then we just output 0. So this is the other way to do it. It's a little bit different, right? This is a case. I think, you always have to end your case, by the way. It's a little more complicated, but this is still a row-level function because it's only operating on a single row at a time. But that worked as well, right? That works just as well as the other method. Like anything else in programming, there's always more than one way to skin a cat. So, different ways you could do this. You could the logic. So why would I use case instead of decode? Decode is pretty straightforward. It's only a substitution algorithm, right? So it just substitutes values, whereas the case lets you do much more complicated logic. So for example, I could do a case when a date falls in a certain range, then do one thing. If a date, if money falls within certain ranges, if the value is in certain ranges, like my promotional stuff, right? If I could output some different promotion things in columns. And we could show that using more complicated case. And I think your book has some examples of that. The last one I want to show you says the last function I'll show you. I know we've used a lot of time. We're almost an hour here on this video. But here's the last one. This is the soundX function. So let's output our customer number, and then our last name, and then our first name from customers. You can use functions. So row-level functions work on your select columns as well as in your where clause. I could have used all of these in the where clause as well. All of these things that I showed you. For example, string to upper or the upper or lower, right? We could put that in a where clause. That way we're comparing. Because if you have upper and lower mixed case, sometimes they won't match. But in any event, let's say I'm trying to find a certain customer, right? A good example is here's the thing is. With customer names, sometimes last names are hard to spell, right? They sound like something, and you try spelling it a couple different ways. But what if I don't know exactly how the customer's name? I was going to say patient because I work a lot in healthcare, but let's say I didn't know how to spell somebody's name, right? Like Smith, for example. Smith is a pretty easy name to spell, but let's say that it was spelled a little different, right? So let's say I spell the name Smith. So where last name equals Smith. Oops, sorry. I have to spell it right here, sorry. Alright, so maybe that's how I spell Smith, right? That's not going to work. I have a Smith in my list, but Smith is spelled differently, right? So instead, we can use the soundX, right? So I can do soundX last name. What that does is it converts the last name to a phonetic version of its spelling, right? How it would basically figures out what would this word sound like, and it converts it to that. So both of these words should sound the same, right? Whether it's Smith or Smith, it sounds exactly the same. So if I do this, I should get back the Smiths. There it is. So it found Smith. So soundX basically lets you do a search based on how the word sounds as opposed to the exact match on the spelling of the words. So soundX is a pretty simple function. It just converts it to its phonetic spelling. But they can be pretty powerful when you're trying to find records and you don't know exactly how they're spelled. So soundX can help you with that. My name is a good example. My last name is spelled Green, just like the color. But a lot of people don't spell green like the color. They spell it Greene. I don't know why people put an E on the end, but some people do. So if I was using SoundX, you could search for green without the E, but it would find all the greens with the E, so I could see all of the greens, whether or not they have an E. Of course, you could also use a like clause to do that, which we learned about before. But this is a good example of, and I think another example was Pearson. So let's do Pearson. See if that works. Oops, I thought I hit run. Let me try it again. Yeah, there we go. Finally finished. So, so you can see here I put Pearson spelled like the airport in Toronto, but it still found Pearson spelled a different way. So I was able to find Pearson both ways. I could do the same thing with Thomas, right? Some people spell Thomas without the H, some spell it with the H. So a SoundX would solve that problem. All right, so that's basically row-level functions. So in our next unit, we're going to cover group functions, which is going to be a little bit different. I kind of touched on a few of those group functions this week, but we'll get into more detail on that next week. And we're getting pretty close here. We've learned a lot so far, so we're getting there. Just a few more weeks left.